Hello, guys. Welcome to today's live session. So, yes, I'll be teaching you electrolysis today. Well, please drop your comments. If you're here, drop your favorite emoji. Let's start. If you're here with me today, Nelson Live Class, let's start. Welcome to Nelson Learning Space. Drop your emojis. Let's start, please. Are you there? Is it clear enough? Drop your favorite emoji. Let's start chemistry. Electrolysis. Electrolysis. Is the emoji coming in? And this one are the usual. Right. How is it now? Can you hear me now? Then let me just want to confirm. Can you hear me now? Is it clear now? Hello, please.
Let someone respond.
Someone should respond. Please, can you hear me?
Yes, sir.
Okay, can you hear me now, right? Hello, can you hear me?
I don't,
Ah, oh. Off the mic. Please, let's be fast. Hello. What are they saying now? Jesus, time is really far gone.
Yes, we can hear you now.
Are you sure?
Yeah,
Okay. It's already 9:30. Our time is a bit gone. Okay. So, uh, please, okay, if you can hear me, drop an emoji, please. Drop an emoji. We need to cover this all we have here. Before at least in 1 hour or maximum 90 minutes this night. Let's cover everything here. I'm starting from the scratch. I have to teach you electrolysis from the scratch. Can you hear me now? Should I start? What is the response? I can't see anything
Yes.
here.
Yes, we can hear you now.
Okay, how many messages are there? Are they?
One.
One. Okay, please keep it coming. Keep it coming, please. How many is it now?
Okay, so,
Okay, let's keep it coming. When it's
yes,
three or
sir.
four, let me know.
Yes, sir. Three now. Yes,
Okay,
sir.
okay, okay. Nice
Yes,
one,
we
nice
can hear
one.
you first.
You can also see the message from here.
We can start now, sir.
Okay, okay, let's start class then. It's all right.
This one,
Okay, let's start now. So, what is electrolysis? Like I said, I'm going to put this here.
Take it here now.
No, don't worry. Thank you. Electrolysis now, it does simply mean, from the word electro, from the word electrolysis, it simply means breaking something down using electricity. That's the simple word. Electrolysis, this is mean breakdown. Then this is means what? Electricity. So breaking down a substance using electricity, that's what electrolysis means. I don't know if you get. Okay, I think yeah. Do you understand? So anywhere you see the word as a science student, you did chemistry, biology, and physics. Anywhere you hear the word lysis, it means to break down. Then the prefix before lysis means what are used to break that thing down. So electrolysis means to break something down using electricity. Hydrolysis means what? Break something down using what? Water. Photolysis, break something down using light. But today we are dealing with electrolysis. So if you are perfectly understand what electrolysis means, now let's talk about the definition. Now, right, electrolysis. Electrolysis is the chemical decomposition of a compound. Electrolysis is the chemical decomposition. Decomposition of a compound. Are they hearing me?
Yeah.
Okay. Is a chemical decomposition of a compound either in molten state or aqueous solution. Either in molten or aqueous solution by passing electric current through it. By passing electric current through it. Are you there? Okay, let me say it once again. Electrolysis is a chemical decomposition of a compound, either in molten state or aqueous solution, by passing electric current through it. Sorry that I'm a bit fast this night. I'm trying to catch up with the time and we start a bit late, 30 minutes late. So let's take it once again. Electrolysis now, we want to be using this place to analyze something. Let's use electrolysis now is just the chemical decomposition of a compound. But this compound now has to be in two states. Now the thing is, electrolysis occurs in a substance that's in liquid medium. That is water state. Oh, there's no water here. Like something like this. Do you get something here? And in that liquid medium, it can come from two angles, either molten or aqueous. So that's the way we can have it. So molten is also liquid, aqueous is also liquid, but different kind of liquid. A molten substance means you turn it to liquid by applying heat to it. Why this one is what? By adding water, by adding H2O. So a good example is, can they see it? Okay, a good example is sodium chloride now. So a molten sodium chloride means a liquid sodium chloride, or a molten sodium chloride means a sodium chloride that turns to liquid when you put the sodium chloride on fire, on heat. Polo pot, charcoal, adogon, that is it. Why an aqueous sodium chloride, NaCl aqueous, just simply means sodium chloride plus water. So they are both liquid. One was through fire or heat, one was through adding water. That is what it means. So once again, last time for today, electrolysis is the chemical decomposition of a compound either in molten state or aqueous solution by passing electric current through it. The word electric, electrolysis. Do you copy now? So with that being said, if you're actually with me, let's come back here. The next thing now, thank you, boy. We want to cover now on this line is stems in electrolysis. Now, you know how I'm going to break it down this night? What I'll do is this: I'm going to break electrolysis down into a grammatical sketch, whereby we'll use it to understand the future. So before we go, I hope everybody has jotted down this thing here, so I can have up the board. I'll give us 5 to 10 seconds to do that. 5 to 10 seconds to do that, please. Have they respond? I think we should be done now, right? So in that case, let's continue. Now, the terms you need to understand, can they see me? The terms you need to understand electrolysis. So what we're doing is this. I'm gonna use the whole board, which is why I said I want you guys to draw and write down the sketch. So let's go now. This is what we'll do. So we'll use this place. I think let me use red now. Let's use this. Let's do this way. So we use this to understand the term. We use this to draw a sketch. Now, I'm going to draw a simple electrolytic cell here, which is something like this. Something like this. Okay. Oh no, let me use red. So I can use black for highlighting. Yes, anything? Anybody drop a message? Sorry, you said? Okay. So this one, let's say this is the positive electrode. This is the negative electrode. Okay. So this blue here, the blue here, then over it the green. Is it all? Are these colors showing?
Yeah.
Thank you. Okay, let me now confirm from them now. Can we see it? It's not showing very well. Oh, I'll change the color now.
Change it to black.
Guys, can you see the green color? Or should I change to black? The green on the, what is it called? Can you see it? Please, I need response to your chat. So
Yes.
you can see it, right?
They are. Yes. They
Okay, okay. That's very good then. That's very good. So let me wait for you guys to draw that and continue. I really don't want to rush the class. I want to be very, very slow with you guys. Okay. I think more people are coming in. Let's Let's patiently wait for them. Okay. Should we go now? Guys, should we go now? You still can see the green, right? So now the first thing I want us to talk about here is number one, electrolytes. Now, what is electrolyte? Electrolyte is that that substance that, let's in a very simple way, that allows the flow of current. Do you understand? That allows current to pass through it. Like for example, now remember we say something earlier that electrolyte is the chemical decomposition of a compound, and that compound can either be what in molten state or in aqueous solution. There's some compound that even in their aqueous state they don't really actually allow flow of electron. I don't know if you get, or even in their liquid form. So not all compounds are electrolytes, because an electrolyte must be able to what, dissociate or break down into ions. And what does ion mean now? That's positive and negative charge particle. Do you get now? So not all substances are electrolytes. So only electrolytes will allow electricity to occur, or only electrolytes will allow electricity to pass through them if they're in liquid form. So some of electrolyte now we have what is called water, salt, NaCl. They are all electrolytes. Are you getting something here? Are you getting something here? So under electrolytes, we have non-electrolytes and the real electrolytes. Then under electrolytes, we have the what is it called? The strong electrolytes and weak electrolytes. If you see such kind of question in OB, when it's this question, this is the electrolytes. This dot here is the electrolytes. Can you hear me, guys? Okay, I'll put that here. Now, this everything here is like a very simple, straightforward. That is like water, sodium chloride, that's salt and acid. They are most weak electrolytes are more like sugar solution. You copy? Now number two, electrons. Should we continue? Now electrodes now, like for example, in your house. Sorry, it's your network, it's your country, it's not my fault. Sorry. I know there's nothing you can do. Say okay. Okay, how is the network now? Abdul Now's Muslim name is it? Hello, please respond. You can hear me. How is the network now? Have they responded?
No.
What they say?
Okay, I'll respond now.
Okay, what's it?
It is still the same.
It's still the same. Please, you have to keep on going. I don't know. You have to come back and watch it. How is this now?
The network is okay.
Hmm?
My network is okay.
Okay, it's okay now, right?
Or if no, for the as far as this one say, okay.
Now, guys, let's go now, guys. So now we have electrode. So in your house now, for electricity to occur, you need two charges, right? Or for it to be received, you need two wires. Like inside your copper wire, you have the black, the red. They call it, I think the live and the negative and the neutral, whatever they call it. Now, same thing happens in electrolysis. Or even in your battery, the battery is like this. You have the top. I think that serve as a positive, and the down serve as negative. You get it? Same thing in electrolysis. You also need such thing. So in that case, also to let the electron flow or the current is. So electron in this case is what is it called? Sorry, I saw a food and I think I was attracted and it took my, I'm an knowledge teacher, so we biologists, we love food. It is not our fault. So let's continue, guys. Jokes aside now. So back to base one. Yeah, mind you, if you're joining this class and I want to eat granite, feel free. I'll pass it across. Life is not as I put it here. I'll eat almost everything. Learning space granite.
It's
Let me see what they say. Okay, so yeah, I'm gonna what is it called? I'm gonna send the piano just on your Bluetooth or your hotspot. Can let's go back now. So in this case now, in electrolysis, we don't actually use what is it called? We don't use wires. We use different kind of conductors. I will call them what electrodes. So we also have the positive and negative electrode now. In this case, or should we change it? Or let's think like this. So this is the positive electrode, and this is what the negative electrode. So what are electrodes now? Electrodes are conductors. This is an electrode, this is an electrode. These two electrodes are like wires connected to the battery. Can you see it? Connected to the battery. So they allow current and electron flow through the electrolyte. For example, now, I think before this electric kettle came to play, the one we used to use before is boiling ring. The boiling water, you carry the boiling ring and then it starts into water. Now, so when that boiling ring enters into the electricity starts flowing through the water. Do you copy? So in this case, that's what this electrode serves as. They allow current and electron to flow through the electrolytes. These electrolytes, don't forget. This one here is electrolyte. Copy? So the battery now passes conventional current like this through the blue flow into the what? The through this electrolyte into this what is it called? Through this electrode, sorry, into the electrolyte. Now we have two types of electrode, which is where we're going to again. Now, can you see here too? Now, the one electrode we have anode. And then number two, we have cathode. Can you see here too? Okay. Is it clear? Okay, we have cathode. Now these are the two types of electrode we have, or the two electrodes we have. So the anode, now under it now, what we're talking about each of them. This is the cathode. Again, electrode. Are you ready? Electrode. They are conductors. They are rod or conductors that allows the flow of electric currents in and out of an electrolyte. Electrodes are conductors, rod, metals, or conductors that allows the flow of electric currents in and out of the electrolyte. The electrode, while the cathode is a negative electrode. Once you drop your emojis, let me know. Are you dropping emojis? Okay, keep on dropping. Are you there? Let me see how many people are there. Okay. Keep on dropping emojis, please. If you are there with me, keep on dropping emojis. Keep on dropping if you are there with me. Okay, you can see your own AAA. If you are here with me, confirm so I know who I know that. Okay, let's continue, guys. Good. So in the anode now, which is the positive and the negative of electron, which means electron enters through the electrolyte. Electron enters into the electrolyte through what? The cathode. Electron enters the electrolyte through the cathode, negative one. That's the first point. So write it down. Electron enters through the cathode. Enters where? The electrolyte. Through the what? The cathode. So the opposite of it, which is anode, electron, electron leaves the electrolyte through the anode. Please, what's about electrolysis is electrolysis need you to understand basic chemical equation and balancing various equation, various reaction. And I need to understand perfectly when I telling my students that you see, various reaction is just more of reduced agents, then I am oxidized agents. If your angle is the reduction, then I am the oxidation. You get same thing. The electrolysis is just front and back, two half reaction that come together to form one whole reaction. So now the first thing I want you to jot down is what in the cathode, electrons enter the electrolyte, while in the anode, electron leaves the electrolyte. Now look at this blue. This blue now. See this blue. This one. This one. The blue is what the flow of conventional current. So the opposite. Conventional current enters into the anode, into the electrolyte through the where? The anode. Write it down. Conventional current enters. Conventional current what? Enters. So the opposite of it is the cathode. In this case now, conventional current what? Leaves. Now before we go deeper now, the chart is getting rough already, which means I want us to be very, very careful. That's why I said if you're not here from the beginning of the class, you might mess your brain up a bit. Now, the next thing I want you to know is this. Let's talk about the electrolyte. A good example of an electrolyte is NaCl. So let's use NaCl. Now let's say let's use molten NaCl. So this is it. This is NaCl as an electrolyte. Form. If electricity part come now, and go through it breaks it down into what? Na, let me write it slowly, into Na plus and Cl minus. It breaks them down into a ion. You get? Now what happens is what? Repels and unlike charges attract. So after breaking it down, what happens now is that inside this electrolyte now, we now have moving ions. Moving ions, that's Na plus here, or let me say plus, minus, minus, minus. They are moving. Now what happens here is that the plus now goes to the negative side to go and stay. So the plus come here. They come here. Plus, 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 plus. Why the negative comes here? Negative, 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 negative. Is it clear? Now what happens is this?
Network, bro. Not be our network.
It is your network. It's your network, not mine. I don't know. I'm sorry. Probably you should. What is it called? Go and buy a good network. A sample of a good network. Plus here, plus minus here. So what happened here is this: the Na and the Cl. Let's like say, hey, let's say this way. Husband and wife went to a wedding reception, but what they did was they tried to separate them into like genders. So we came together. I and my wife. I'm not married. If you want to marry me, do your bride price. Sorry, your groom price, whichever one you come with, any price. Yeah. So I went to the wedding reception with my wife now, and I got there, and that separates us. So I, as a man, now will go to what the men's quarter and the woman. That's what happened. So NaCl comes associated due to the electricity passing through it. Now in this place now, this electrode, remember electrode, this is minus, and minus is what? Negative, yeah? So minus positive. So this anode here, this electrode they call cathode. ION. That's what we have the word from. Cation. And cation are what? Because what catalysts are this? Positive ion. That's how the word was generated. So which means in the cathode, positive ions are being formed. Write down too. Positive ions, can I see this please?
Yeah.
Positive ions are being formed. In the cathode, positive ions are being formed. Now what is positive ion called? They are called cations. They are called what? Cations. Do you get something here? Are you sure you're getting it? Are you sure? So that is where the word comes from. Now, if you apply the same principle to this place now, where the negative people go, negative people now are what? They are the an, which is anode now, from the word anode, and then the ions. So anions. That's what it's being called. So anions are negative ions. So the positive, so reverse here, write it down. Negative ions are being formed. They are being formed. And what are they called? They are called anions. Bracket anions. Sorry, I think down here my writing is getting more worse. So manage, please. If you cannot see it, use eyeglasses or you ask me. Sorry. Is this zoomable?
Yeah.
Okay, okay. Sorry, if your network is fluctuating, sorry. No, the down part is the main thing. Can they see
I
it?
can see it.
Hey, I can't see it though.
See it here now.
Okay, let's go. So I think that's chemistry. And I tell the students that the beginning part is always interesting and everybody thinks it's simple and to go deeper. But one thing about that beginning part is that if you understand that beginning part, it helps you to understand that ending part. Copy? Copy? Good. Don't forget tomorrow we're still coming live again, and on Saturday we're coming live. But every Saturday is for medical students. Purely biology. Don't miss it. Now let's go back now. Okay, the next thing here is this. There's something called redox reaction. That's reduction and oxidation. Now, in terms of electron transfer, reduction just simply means electron gain. Now, I want to go on the board now. You off the mic? Okay. So now, I was talking about reduction and oxidation, right? So reduction and oxidation. So reduction just simply means what? Gain of electron. From the word, you can call it as big. Reduction is gain. While oxidation is what? Loss of electron. Do you copy? So oxidation is what? Loss of electron. Now what does it mean now? It means that for oxidation to occur, you must lose electron. Now look at these two places now. In this place, in the cathode, electron was what? Was gained. Do you understand? Electron was gained. Enters. Electron was gained. Right? Let me calm down. In the cathode, remember this flow, right? Remember this flow. Electron enters in the cathode. Electron was gained. While in the anode, electron was lost. Do you get? So if electron was gained in the cathode, what does that mean? It means that reduction occurs where? In the cathode. UTME students, if you know you are doing any exam that involve OBJs, objective questions, or MCQ, multiple choice question, open your head, open your ears and learn these points I'm giving to you guys. Because that's why I tell you guys that most of the objective kind of questions are questions that they will ask you, questions you already know, but they don't know it. So if you know, you have to be smarter than the examiners. You have to maneuver around the corners they give to you. It's about internal senses. It's about inquisitiveness. Be very think in their shoes. Walk in their shoes. Sorry, you think like the way they think. Now, without one missing, write it down also under this. In the cathode, reduction occurs. I don't know if you can see the board again. My board is already full. So yeah, reduction. You can see it again, right?
Let me see.
You can see it.
Go there. Let me see.
Okay, reduction occurs.
No.
No, right? Oh. Okay, so write it there. In the cathode, reduction occurs. But let me knock this one off. Right? Please, if you're here with me, can you tell me, can I rub these two parts off? Please drop your comments. Can I rub them off? Drop your comments. Can I rub them off? Okay, let's continue then. Where's my duster? Who took my duster there? Okay, I thought it's one of you guys that is watching me live. So let's rub it off. So where did I stop? Don't tell them. So type where I stopped. Where did I stop? That's on top of the board. What was the last thing I said? What happened somewhere? I said something happened somewhere. What happened? Let's see if you're following me. Yeah, I can proceed triple A or whoever is online with me. Type out where I stopped. What did I talk about last? I'm waiting for you guys to drop your comments. What was last thing I said? Something happened somewhere. Hello, everybody's quiet. God bless you. Who is that person? Abdul Mumin, God bless you, boy. God bless you. Don't worry, I owe you something. Send me your account number and I'll drop something for you. 15 naira. You are blessed, boy. 15 naira for you. Yes. If you want more, I'll add 10 naira to it. Now let's go now, yeah? So yeah, reduction occurs in the what? In the anode. Reduction occurs in the anode. So the opposite happens in the cathode. Oxidation occurs in the cathode. And what's oxidation? Oxidation is loss of electron. While reduction is what? Is gain of electron. Do you see it? So loss of electron occurs in the anode. Gain of electron occurs in the cathode. Now let's talk now. Let me break it down deeper for you. Are you ready? So remember that this Na plus. Now I'm going to use this box now to explain something to you guys. Are you here? Are you ready? Now this what I was explaining here consists of, if you're watching me from Nigeria, it consists of the SS1 grade and the SS2 grade. You understand? Like that's what it consists of. I'm going to explain something to you guys now. Every atom in its natural state has the fact that P, number of protons is equal to what? E, number of electrons. You can't see it, Abi? Okay, let me use black. So every atom is in its neutral state. P is equal to E. That means number of electrons is equal to what? Number of protons is equal to what? Number of electrons. And what does this mean? It is only when an atom starts reacting with another atom to form either a molecule of a compound or a molecule of elements. That's when the giving and taking or the sharing occurs. But in electrolytes, there is no sharing. Anybody that has electrolytes here has to be a give and take compound called a ionic compound or electrolytic compound, which means when they give and take, the giver is plus, the receiver is what? Minus. So I think if you are Yoruba watching me, the giver is Anima Shaun. The giver is the giver. He has money and he gives. The Dangote, the OBO. The receiver are we, the poor, the poor ones. You guys now. Okay, let's break it down now to this style now. Let's use man and woman now. So man gives. Don't get it twisted. Don't get it twisted. Your mom is lovely. Your sisters are beautiful. And they contribute to the society perfectly well. But to make it simple for you, let me make this example. Please and please don't get it twisted. So let's say the man gives now. The woman now receives. Huh? So in this case now, the one that gives, they are mostly chemistry. They are metal. All that receive there was non-metal. So for example now, anywhere you see Na plus, it means it has given out electron. But how many? One. That's not plus. O2 minus has received electron. How many? How many? 2. Al3 plus. The plus means it has given out. How many? 3. SO4 2 minus has given out how many? 2. Mg2 plus, minus is received. He has gained how many? 2. Mg2 plus has received 2. Let's take this one out. Cl minus has, minus means only basic, a debtor, a receiver, a collector, a amajiri, a beggar, a bambiala. So this Cl has received how many electrons? 1. You copy. So now, let's go back again. Since you understand that, what will make you positive as an atom? Sorry, you're even at A already. What will make you positive means you have actually what? Giving out. So let's use this guy for example. No matter what was here was NaC plus, right? Na plus and Cl minus, Na plus and Cl minus. Now, since Na plus is in the cathode here, so let me clean this up also. I want to clean this one too, guys. This is a live class, meaning the borders will be rubbed off. So please keep on writing all the necessary points I'm dropping. So let's say this space is the cathode, this space is the anode. The cathode and the anode. So what is in the cathode is Na plus. What is in the anode? So what is in the cathode is Na plus, and what is in the anode is Cl minus. Now Na plus is here. Normal Na is here. Normal Na is supposed to be 281. Normal Cl is supposed to be what? 287. Then Na gave out one electron or lose one electron, lost electron, lose electron, and become what? Na plus. So he has lose this one electron and become what? 2,8.
It is not clear.
Ah, it's not clear. Okay. Hey, shit.
Writing or what?
So it's not clear. Okay. Which part is not clear? Let me see. Ah, can you zoom it? How is it now? I think it should be clear now, right? How is it now? Please respond. How is it now? Oh. I think I get it now. Let me rewrite it. I think I get it. I said here is negative, the cathode. Here is positive, the anode. So I'm trying to understand what happened in the cathode and the anode.
It is not your
So how is it now? Oh, better. Good. Let's go now. Better. So now, since Na has given out one electron, become what? 2,8. So Na plus is 2,8. Na normal Na is 281. Cl minus receive or gain. He gains to become what? Cl minus. He has given out 1. So he has added 1 to this and become what? 288. How to prove that anode oxidation occurs? So that losing of electron now occurs in the anode. Do you remember? Cl minus is here. But anytime, is there any question? Anytime electrolysis occurs, there is what we call libration. In fact, we will learn that during the laws of electrolysis. This is straight to. We will learn that during the laws of electrolysis. I think the first law states that Faraday, he was my friend, a very good friend, like a Faraday. Faraday is my very good friend. If you think I'm lying, I'll show you pictures. So now, Faraday said there are two laws of electrolysis. The first one, it says the mass of a substance liberated during electrolysis is directly proportional to the quantity of electricity, what is it called, that passes through the electrolyte. We are not talking about the law now. All I want you to know is that what these two guys, something was liberated here and here. And if here Cl used to be liberated, it will not come out as Cl, it will come out as what? Cl gas, which is chlorine gas. You cannot breathe in oxygen in here. You can only breathe in oxygen gas. Do you get now? So this place, as of here, this Cl here is still minus. So what happened here is for this Cl here, back to this place. For this Cl here to be liberated, to actually be liberated, to come out as chlorine gas, this Cl must lose one electron. That means my name is Nelson. I have a friend, his name is Peter. I broke Peter 100 naira and I keep on insulting him in school. We are both in SS1. Peter, you are owing me money. Oh. You know you are owing me money. For Peter to become normal, to become free, he has to return my 100 naira back to me. For me, the giver, to shut up my dirty mouth, I have to collect my 100 naira, but I will collect and no consign you. Now my 100 naira. Is it your own? No. So this Cl now, we lose this electron. He has lost the electron. Remember this was anode. He has lost that one electron here. He has lost it to become what? 287 back. So oxidation of what? Occur. Do you see the way this thing works? Do you see the way it works? This Cl minus, for it to become normal Cl and get liberated outside this place, it must lose that electron back. So from 8 minus 1 to become 287 to become normal chlorine. Then in that case, anode, oxidation of what? Occur. Same thing will happen here. For this cathode, for this Na plus to be liberated, if it will be, then this Na, we gain back this electron to become what? Na. Reduction of occur. Guys, do you understand? Do you understand? Are you sure you follow? Are you sure? So if you have any question, drop now. So what I'm going to do is this. Due to our timing and everything, and you guys have to go to school tomorrow, most of you in this live class, I'll just skip all this explanation. I'll treat 2 or 3 calculation questions under electrolysis, and then that's under the most, and then probably in our next chemistry class, next electrolysis class, I'll break down how to understand what will be liberated in each compound that is what is it called that we run electrolysis through. For example, electrolysis of acidified water, electrolysis of copper sulfate, electrolysis of brine, and the likes. So if you have any questions about this, I'm going to give you 5 to 10 seconds to drop them in the comment section. And if you have any question, drop your favorite emoji and say learning space. Type it there, and then we'll continue. Okay, I think that's being said. Let's start the calculation question now. Now, before we enter the calculation, we have to state the first law because I'm going to solve just maximum two questions because of timing. Maximum 2 questions on the first law. I think next class we're going to do it, the remaining parts, electrolysis 2. And what we'll be treating there is just basically um, electrolysis of common substances, and then we'll treat Faraday's second law of electrolysis. Are you there? Now let's go. Are we good, boy? Can we fly? Okay. The first law states that the mass of a substance, the mass of a substance liberated at the electrode during electrolysis. Can I see it? How far? Okay, during electrolysis is direct proportional I'm taking my time to write it for you guys. Proportional to the quantity. This cube means quantity of electricity passing through the electrolyte. Passing through what? The electrolyte. So guys, this is the first law. To derive it, let's just say M is directly proportional to what? To Q. Right? So it is directly M is equals to the constant we're using here is electrical equivalent. Let's use E to represent it. It's then is equals to what? E Q. Right? So in this case now, M is the what? The mass. E is the electrochemical equivalent. And let's see what? Are we clear? Are we clear? Electrochemical equivalent. And then Q is what? Is the quantity of electricity. Now, if that's the case now, if Q is equals to IT, if Q is equals to IT, see what my T look like Nigerian problem. If Q is equals to IT, therefore, I'm going to say what? M is equals to electrical equivalent and then IT. Then this is equals to M over IT. I don't know if you get it. And mind you, what is I? I is equals to current. Then T is equals to time. The unit for mass is, oh God, my page is already full. As I've written earlier, the unit for mass is grams. The unit for Q is coulombs. The unit for I is ampere. The unit for T is seconds. Please just that before we solve. Kindly jot that down before we solve. Okay. Okay, just that that's our sub question. I hope we are done.
Yes.
Okay, let's go then. So now let's start the first question now. Okay, I think it's clear enough. Sometimes you can actually choose to write that electrical equivalent as Z. Anyone you use. If your exam or your test will choose E, use E. If you use Z, that's let me write it so you can know. Like something like this. This E can actually be also be Z Q. It doesn't matter. Anyone that is chosen or Z that has kind of sign is correct. So get it please. So if you want to use the unit of E, which really they only ask for the unit, it will be what? GC. So G over C. That's G over C here. G plus C. So number one question, sorry. Number one question, are you there? A current, please I can't really write again, there's not much time. I'm being very time conscious and I'm release you guys as early as possible. Like we agreed. Don't forget to come early tomorrow. Tomorrow we're going to be treating chemical kinetics, and then on Saturday is still biology. Saturday, every Saturday is for medical students. We're treating biology, biology, biology. I don't know if Sunday yet. Yes. Don't forget to follow me both on TikTok and YouTube. Nelson Learning Space. Now, question one. A current of 25 ampere, a current of 25 ampere is passed through a solution of CuSO4. Is passed through a solution of CuSO4. Sorry about asking the question. There is no time. A solution of CuSO4 for 30 minutes. For 30 minutes. Calculate the mass of copper. Calculate the mass of copper. That's what I'm looking for. A moment, please. Just give me like 5 seconds. So, as I was saying, sorry, I'm back. So, a current of 22.25, oh, sorry, it's 2.5 ampere. Yeah, is passed through a solution of CuSO4 for 30 minutes. Calculate the mass of copper deposited on the cathode. Now, this is the question. Let me say it again, if you're writing it. A current of 2.5 ampere is passed through a solution of CuSO4 for 30 minutes. Calculate the mass of copper. The mass of copper. Mass of copper liberated at the cathode. Are you ready now? So in most questions, they'll give you the atomic mass of copper, which is what? Cu equals to 65. Now let me explain how to solve the question under electrolysis like this. I'm going back to black. Before you solve this question, first understand this. Oh, let me do this way, yeah? If you are with me, thank you. Let's finish this class once and for all. 1 Faraday of electricity, or 1 Faraday, will liberate 1 mole of a univalent metal, univalent substance. Example of univalent means it's not that only just one, like the valency on top, that minus or plus is 1. Example, H plus, Na plus, F minus, Cl minus. A question? Sorry? Okay, no problem. Let's continue. So that is if the other is univalent, in that Faraday, 1 Faraday. So which means 2 Faraday will liberate a divalent, 1 mole of divalent substance. For example, O2 minus. Which other one gives here? Mg2 plus. They need how many valence? How many Faraday? 2. 3 Faraday will liberate the one that has 3 plus. That's trivalent substance or trivalent metal or trivalent ion.
I don't see what you are writing.
It's not clear. Is it clear now? I think it should be clear now, right?
Yeah. What's your Facebook?
Sorry. Let's go. So, example Al3 plus. Let me say it again. 1 Faraday will liberate 1 mole. 1 mole is normally the back of a univalent element. Now, if you understand this, that I already gave an example, let's try this now. I want to be sure you understand it. So, how many Faraday will liberate, hope it's clear. How many Faraday will liberate 3 moles of O2 minus? Drop your answer. How many Faraday will liberate 3 moles of O2 minus? Be fast, please. Yeah, since. Okay, attendant by the keys. Attendant by the keys. Your answer is wrong. Then Ahmad Isa, you said the one I wrote with blue marker is ampere. Why? How? I don't understand. I don't get what you're talking about. Oh. I hope you have not passed there. Ahmad Isa, explain yourself again. I don't understand. Okay, please write your question. Attendant by the keys, you are wrong. Oh, yes, it's 6 Faraday. Yes, Abdul Mumin, you are correct. Abdul Mumin, you are correct. Yeah. So now let's go now. It's 6 Faraday. Let me explain it for anybody that is there. Normally, all 2 minus we need just 2 Faraday because he has his divalent. Then how many with 3 needs? 3 O 2 minus. You can actually cross multiply. So 2 times 3. So it needs 6 Faraday. You copy now. So one last example under that. How many Faraday will be required to liberate 4 moles of aluminum 3 plus? Yeah, just the answer, everybody. Just 2 or 3 answers, and I'll continue. We have spent 1 hour, so we have maximum of 1 more minute. Okay, let's go. After the answer.
Yes, now.
What do you say?
They're asking you either they will copy it.
I mean the I you wrote at the board, at the other side of the board. No, this I here or red. And this I here, the use of I is ampere, and the I also this current. This is for units. What I wrote here is for units. Units. I don't know if you understand. I think I have explained it. So the use of mass, gram, use of Q columns, use of I think it's even UO, not OU, I don't even know. I ampere, T seconds. So that's it. Please, I think I've not given the answer of that word you called, of that number, the second example. No, it's not 3 Faraday. Oh. It's not 3 Faraday. Let's solve this, please. 1 Faraday, how many Faraday will need Al3 plus? 3 Faraday will liberate a normal Al3 plus. But then 4 Al3 plus, this is 1. That will be 3 times 4. So 12 Faraday will liberate 4 Al3 plus. I think let's stop there and let's solve the question that we have on the board. I think we don't even need this again. So I can hastily write the question on the board. So we can solve from there because some of you are very smart, ironically. So the question says, what was even the question again? I think the question says, maybe I'm to bring my code. Maybe. It's going to be my code.
Maybe.
Well, that freezer, please. Okay, said a current, sorry? No, it's not on my phone. A current of 2.5 ampere is, can I see it? How far?
Yeah.
Is passed through a solution of CuSO4 of CuSO4 for 30 minutes. For 30 minutes. Calculate the mass. I'm going to shorten the question. Mass of copper liberated. So let's stop here. So the question now, first of all, let's try to get the ionic quotient. Cu is divalent, is 2 plus. With me, Cu2 plus, we need 2 electrons, right? You have to rebalance. The question? Okay, no question. We need 2 electrons to rebalance, become Cu. So which means how many Faraday will liberate copper solid, which is divalent. If you need 2 Faraday to liberate copper. Right? Now what I want to let you know that 2 Faraday is also 1 Faraday is equals to 96,500. So in that case, 2 Faraday is what? 2 times 96,500 will liberate just one copper. And one copper is what? 65. Will liberate 65 gram. That's the first step. You have used this one to know that copper will need what? 2 Faraday. I know that what 1 Faraday is 96,500. So 2 times 96,500 will liberate 65 gram. So the question now is this. They now say this quantity of electricity here, what mass will it liberate? So let's find this Q. This Q is equals to what? Q is equals to IT. What's I? 2.5 times what's T? 30 minutes, right? So let's convert it to seconds. 1 minute, I'm being very slow for you guys to understand. And let's see also. And I hope it's clear for you to zoom. So 1 minute is what? Is 60 seconds. So 30 is what? That's 180 seconds. So 2.5 times 180, that's equals to, I think that should be like 360, 450. That should be 450, but let me confirm so I don't make any single mistake. 2.5 times 180. Okay, that's 450. So 450 colon C. Do you get it now? And let's have to go down. Now, let's come back here. He said, 2, I want to go down. Okay? He said, 2 times 96,500 will naturally liberate 65. So what will 450 liberate? That's what the question asks us. So cross multiply, and this is it. Okay, that will be 450. That will be 450 multiplied by 65 divided by 2 times 96,500. So you are solving and got the final answer. For 450 times 65 divided by 2 times 96,500. Everybody solve it and got the final answer. 450. I'm waiting for you all. So drop your final answer. So what my final answer is equals to the mass. Is equals to whatever the grams.
Someone is responding. 60 times 30 is 180.
You said?
Yeah, 1,800. 60 times 30 is 1,800.
1,800. Ah, it's true. Oh, that was a mistake. That's true. There are 2 zeros there. Oh, Jesus. Okay, let's change it. Let's be correct though. I made a mistake. So what I think I did 3 times 60. Oh. So, but please, there was a mistake. That's 2.5 times 1,800. So that'll give us 4,500. So we convert. We convert. That was a mistake. I removed 1 0. Yeah, so redo it for me, please. What? Okay. I was doing 3 times what is it called? 3 times 60. So what's the final answer, please? What's the final answer?
I'm gonna respond 1.5.
Okay, I can't 1.5. If you get 1.5, you must have used that for 450. So it's 4,500. Correct yourself, please. It's not 1.5. It can't be 1.5. Triple A is not 1.5, please. Yeah, you are correct. Bolanle, you are correct. It's 15.156 or 15.16. Yeah, no, it's not 1.5. I'm mad, Issa. It's not 1.5. Because I made a mistake earlier. I used 3 times 60 of 3 times 60. Correct that, please. So the final answer is 15.16 or 15.156. Ngozi correct. Ngozi, you are correct. Abdul Amin correct. Sorry, Abdul Mumin. Sorry, Abdul Mumin. I think with that being said, let's close for the day. So I'll give you a final answer, your classwork of the day for you to go and stop right now.
But you write 18.
Huh?
But this is 18 you're right.
It's not 18, no, it's 6. So
Oh.
it's my beautiful handwriting. It's not 18. No. So guys, I think we'll close for the day and I'll give you a pizza, your nice pizza to go and eat at home. Make sure you eat it and make sure you come with it as a solution. I can drop it on any of my Facebook, what is it called that you see, Facebook post or my next video post. Just come there on this live and drop it. Drop your solution. Snap and drop. Snap it. Don't do it for me with AI. Solve it on paper and drop the answer. Don't forget to share our videos and our next live class to your friends. Let's meet again tomorrow to deal with chemical kinetics. Okay. Night pizza. So night pizza. I'll only give you 2 questions for your night pizza. So what quantity, can they up is clear or is too far, of electricity is required I think 2.16 gram of silver, 2.16 gram of silver from a solution of silver. So I'll help you this night by telling you the valency. Ag is 108. That's the mass. The valency is +1. Number 2. So, but up with that, in what is it called? The valency is 1. There's no plus because it's not a solution number. So the valency is 1. Up with that, most of your exams, they don't give you valency. They only give you the atomic mass. So please don't rely on this. Don't rely on this, please. So the number 2, I'm going to drop the solution to this question though, probably before tomorrow live class. I'm going to drop it as a short video. Number 2, a steady current of 3 ampere. Is there any question?
45,000.
So the last question, the answer I think they use 45,000. I use 45. Yeah, if you use 45, you are correct. But if you use 450 triple A, I think you are opposite right. You're not wrong, but you're opposite right. Okay, guys, you have 2 more minutes to make it 1 hour. My promise is to make it 60-minute class. Let's finish this thing up. A steady current of 3 ampere is passed for 1 hour 20 minutes. Please don't forget to time, even in physics, is measured in seconds. If they give you time in hour, convert it to seconds. If they give you time in minutes, convert it to seconds. Don't forget to of 3 ampere is passed, except the question or the examiner, specify that you are using minutes or hour. That's 1 hour 20 minutes. True. Is there any other message? Is there any other message? No. No or yes?
No. This one is right. Yeah, maybe.
my eyes very rough. Can I see this, please?
Yeah.
Ah, no, let me make it like this. Let me arrange it that way so it's be simple for them to understand. Number one,
Let it be good. No.
let's be bold.
Then let's say that.
I think you cannot. Okay, if you zoom it, if I make it bold, the board will full.
Use the other side now.
No, let me finish this, please. Can they see that bottom part?
Yeah, they can see it.
So even for this one also, I will help you out with the valency. Like I said, please don't get. Can I see this last place? So please don't get used to me giving you valency. In questions, you might need to have the valency by yourself. You understand? 207. The valency is 2. So I will allow you guys to write the question. I made this 2 hour, 1 hour to close for the day. Thank you. And welcome to Nelson Learning Space. And don't forget to subscribe and share. Subscribe and follow me on TikTok. Next week, I'll be going live more on TikTok. So that's it. Thank you and welcome to Nelson Learning Space. So, hi guys, this is your night pizza. Make sure you do it and submit it. Snap and drop it on this comment section of the YouTube video. And before tomorrow, I think tomorrow live class, I'll have solved it and drop it. Thank you so much. Hi. If there's any question, drop them. I'll answer them all. Is there any issue?
I can't see the last one I'm coming. I want to take a screenshot first.
Is there any issue?
Don't worry, I can solve it. I will zoom it, but now it's close.
Should I zoom it so you can see the bottom part? If there's any question, please don't feel free to drop it in the comment section. Okay, bye. Bye. So will you zoom it now?
This is the problem that my phone is having.
I can't hear the problem. You're not small. I can't hear anything.
Not you. I wanted to screenshot.
Don't worry about this control. Okay, guys, is it clear now? Hello, guys, is it clear? Okay, okay, so write it now.
So I hope everybody has written a nice pizza now. I think we can go and close and roll for today. Guys, thank you so much for this night. Let's meet again tomorrow. Good night, everyone. How would I end it? Yeah, thank you, thank you. Have you too. Have a great night. Have a wonderful night to you all. I wish you the best and best in your education endeavors. Thank you so much. Good night, sir. Yep, you're all welcome.